Okay, functions 2. All right, so the functions 2 problems look very similar to this, just the only difference is maybe the function is different, but everything is the same. Now, what you're trying to do in these problems, well, the first thing you got to do is fill in the table. Once you fill out the table, if you know how to read the table, then you'll be able to answer questions B and C without too much trouble. All right, I know in the Zybook they prefer to use these bubble diagrams for functions, and that's the way that I learned functions, is with, you draw these things like this, and then you have the function going across f. This is the domain is on the left. That's the natural numbers in this case, and the target is on the right. That's the integers for this function. And you draw arrows going across like I'll do in just a moment. But because at Boise State in Calc 1, which is a prerequisite for this class, because in that class you do a lot of filling out of tables and thinking of things in terms of tabular data, and because tables are so important, I've chosen to make my my data structure as a table, okay, instead of these bubble diagrams. But I will draw but anyway, okay, sorry, I'm a little wordy. What can I say? I'm a teacher. Okay. Now let's see, you've got, let's say, -2, -1, 0, 1, 2, 3. And this ... extends upward as well, because the integers go into the negative as well. Okay, and so f of n equals n. So we have, so it's 1 goes to 1, 2 goes to 2, 3 goes to 3, and so on. 0 goes to 0. Okay, now the one thing to notice is that the integers don't get hit. The integers don't get hit, or not the integers that don't get hit. Some of the integers get hit, but not the negative integers. The negative integers do not get hit. Right, okay, so filling out the table, we would just say 0, 1, 2, 3, 4. But the negative integers, there's nothing that comes over to the negative integers. So we have do not exist here, do not exist here. All right, so that's the first part. Now looking at part B, so if the function is onto, meaning that for every element of the target has some element of the domain that comes over to it. So if the function is onto, then you just skip to part C. If the function is not onto, then you give a counterexample. So if it's not onto, you find a value for, you put a value for y. Now the idea here is that, remember that f of x equals y. This is in the target. The x is in the domain. So let me be clear, x is in the domain, but f of x, which is y, is in the target. Okay, and you can see that from the table immediately if one thing about the table is, if you have two things about the table are correct. The first thing that must be true about the table for you to read anything off with any certainty is that everything in the domain side, everything on the left-hand side must be unique. So all different. Unique means all different. So all different there. Okay, so if all the values in the left-hand column, the domain column, are all different, then if you have any values in that left-hand column, that have a D and E in there, then that is your answer here. So you could pick -2 or -3, doesn't matter. I'll choose -2. Right, and so let me emphasize that what I said earlier, when I misspoke when I said the integers don't get hit. That's not true. Some of the integers get hit, namely the positive integers and 0. They get hit by the function. But these ones here, all of the negatives, right, they do not get hit by the function. So the function is not onto. It's not onto because the entire target does not get hit by values coming across. Okay, and notice how we've satisfied this, what I have written here in part B. If it's not onto, we want to write a function for y such that y is in the target. Okay, -2 is over here in the target, right? Remember, this is the target. Right? -2 is an element of the target. But there does not exist any x in the domain. Okay, this should say x here. Should say x here. There does not exist any x in the domain such that f of x equals y. Okay, so there's no x in the domain such that when you apply the rule to x, you get -2. Okay, so that's why it's onto. And that's our example there. All right, so the same thing goes for 1-to-1. If the function is 1-to-1, then you skip. You don't have to do anything. But if it's not 1-to-1, then you have to provide a counterexample. This function is 1-to-1. All right, so let me talk about that just real fast. Okay, so remember, a function is not 1-to-1 when you have this situation here. You have something here, something going like this. That is not 1-to-1. So if you don't have any situations like that, then you're not 1-to-1. And so let me show you how an example of when something would not be 1-to-1 with the table. All right, so you have, this is the domain over here, right? And this is the target over here. This is my domain. This is my target. A little bunchy there. That's my target. So now let's just say that, this is not going to be the way, this is not the way it is with this example. We'll see this with other examples. But let's just say that instead of a -2, or instead of a 2 there, we had a 1 there. Let's just say that we had a 1 there where the 2 is in the target. Okay, what would this mean? Right, this would mean that we had a 1 here, and then see here we have a 1 and a 2. So we'd have a 1 and a 2 both going to the same thing. Right, that would not be 1-to-1. And so really, to tell if something is not 1-to-1, when you look at your table, the question is, do you have any repeated values in the second column? Do you have any repeated values in the target column. And again, this revolves around, this only works, this reasoning with the table only works if this left-hand side of the column, the domain side, everything is different. All different there. So unique, meaning all different. Everything is unique over there, everything is all different over there. Okay, so if everything is all different, if all the numbers are different. Now I don't mean that, so I guess I can see that some people might be like, well, hey, those aren't different, those both say the same thing. Okay, so you can have D and E repeated more than once. What I mean is all the numbers are different. So let me all numbers are different. D and E is not a number, it just means does not exist. So as long as all the numbers are different in the left-hand column, the domain column, if there's any repeated values in the target column or the range column here, then I guess that should actually, let's call that the target, not the range. If everything is, if there's any repeated values in the target column, then it is not one-to-one. And we'll see examples of that coming up soon. But in this example, we don't have this situation here at all. Two inputs going to the same output, and so it is one-to-one, and so we skip that part.